remember the ureset function I was showing you before? When it goes through a folder, there's a folder where it finds all the commands. It reads every single file and runs this function here. And this function will tell you what's the name of the user commands in that file. In this case here, there's 2 user commands. It will also tell you what the short description is, and the group and the parsing rules and everything. And that is kept in Quad-C. And also the name of the file at the same time. It has the name of the file, I just read it. So all that information is kept in Quad-C. There's a vector of all user commands. In this case I have 70 elements. And it's 70 namespaces that contain that information. And well, it's very easy to find. If you say I want to have command time, then I just look in the list. Command time is there. Here's the file. Read the file. Read it. Saves you from having to remember where you put it.
And Quad-C is associated with the session.
Yeah, that's right. Quad-C is, like I told you before, it's a separate thing. It vanishes as soon as you off your session.
Right, but I can create namespaces in Quad-C.
Oh yeah. Quad-C is just like the workspace. It's another workspace. People don't use
workspace. It's a session.
I'm sorry. I should say it's not a workspace. It's a namespace.
Okay.
There are 2 namespaces. The workspace, as we call it, since we've called it for 40 years, is really a big namespace.
Right.
It's the mother namespace, if you want. So is Quad-C. Okay, there's something interesting I just want to tell you about for 1 second. Diane here did something that raises an interesting point. The user commands are found in one location. And one way to find out where they are stored is if you do bracket settings. It will show you your settings, your salt settings. And one of them will say command directory. And this is where all your commands go. So normally what would happen is that when you save your user command, you would put it there. If you put it into a different location, your file, then when it comes time to execute it, the system will go look into this folder, and if you ask for your command and it's not there, it will say it's not, even though you have actually saved it somewhere else. When you save it, the user command doesn't know that your command exists yet. So you've saved it, you didn't save it in the location where all your commands are. When you try to use it, it doesn't find it. So you have 2 choices. Either you put your user command in the same location as all the other user commands, or you tell the system to also look at the other place. So the way to do that, if you look here, I go settings, and you can see that my command directory is APL training WPF user commands, semicolon, which means this is one place where you have to look, semicolon, and then that's the second place where you have to look. So at the moment, all my user commands are stored either here, which is the default, or here, which is my personal step for this presentation. So I have 2 locations where my user commands are. If you save it, if you don't save your commands in either of these, they will not be found. You have a choice. Either you bring them in one of the ones that are shown here. In your case, it will be only that. Or what you do is that you say settings, command directory, and then you say, for example, let's say that I decided to put it in temp. I say add, just like an APL catenate, / and let's say I've decided to use temp. So I tell all my user commands, I'm going to put a set of user commands in temp. Then now if you look, these are 3 places where the system is going to be looking. In temp, in APL training, and in this one. And now if I have any user commands in here, they will be found. So the reason why Diane didn't get her user command is because she saved it in a location that wasn't in this setting here. So when she asked to get her command, the system went, tried to look for it, said, nope, sorry, can't find it.
When you save a command, where does it put it? In the first one or the last one? Or
When you say what?
when I save a new command, where does it go?
By default, it goes over here. You should only have one. If you look at your settings, you probably have only one location. You don't have any semicolon that separate the paths. So what Diane has to do now is either change her settings or just change the file location. By the way, you don't have to type the user command name, the full name. If, for example, settings here, I'm typing settings, but there's very few commands that start with the letter S-E-T. In fact, there's only one. You see, if I've done only bracket S-E-T, it figured out there's only one command called that starts with S-E-T, settings. But if I had tried just bracket S, it would say that it doesn't understand this because there's probably another command. See, command S is not found. There's probably another command that in the list of. And if we look, there's a user command called svn delete, svn. So there's about a dozen commands that start with S. It didn't know, so no, sorry, command S doesn't mean anything to me. I don't know that. Well, what I was going to do, there's all these user commands here, very good utilities. I'm not going to go over the entire thing because there's 70 of them and we're going to go here until next week. But I'm going to go over the main ones. I think we should do that. Let's go over here's the user command to find how long it takes to run an expression. So for example, I want to know how long it takes to run the sum of the first 1,000 numbers, the sum of the first 10,000 numbers, and the sum of the first 1,000,000 numbers. Okay? So I run it, and it takes no time. So this doesn't give me very much information. I ran it once. So what I want to do is say, see, this one takes a switch called repeat. And you give it the number of times you want to repeat, or the time in seconds that you want it to repeat. So I could say repeat 1,000 times, but in this case, if I add an S, it means repeat for 1 second. So and then it's going to average, it's going to calculate the number of times it ran it, and then it's going to average it out. So you see that the first time it ran it took that many microseconds per, and each time it did it. So ran it for 1 second, that was the average. Ran it for 1 second with this expression, that was the average, and so on and so on. So this is an expression that, for example, you want to know how long it takes to run something. Is it faster to do it this way or to do it this way? Then you can run it. You say CPU, you try your expressions, and then you see how long it does. Now remember one thing. In this case, you can see I have no quotes around each one. There's 3 things in it, but that's okay because there were no spaces in it. If you have to use spaces in your expression, remember to quote, either quotes or double quotes around. And that will put your arguments together, keep your arguments together. Okay, disp, you know the function disp in the defense? You have it here as a user command. Function display is also there. So instead of having to copy over the display function from the display workspace, we can just use it directly from here. Let's say you want to find something. You know Windows is very poor at trying to find files. So if you say, I'm looking for something called dest_x. I know I've seen this, and it's in a directory, it's in a folder that I've seen here, and the extension of the file is of type .r. And I know I've seen this in that directory. I just can't remember what I've seen it. So you can ask, and then it goes. It says, okay, I found in this the_animal.r, I found 4 matches. Here's line 22, 23, and so on. Here's where I found it. In this file I found it there, in this file I found it there. So it allows you to look for text, or even regular expressions if you want to. It's full regular expressions, so if you've got something complicated, it will find it too. Here's an example of a regular expression where you would be looking for something in assignment, followed by a minimum number of characters, followed by the letters APP, which have no letters in front. That's regex. You don't have to understand what it does, it's just to give you an expression. And then this one would be done into this directory, and the extension would be, this means it's a regular expression. The extension by default is dialog.
Is there documentation on that?
Come again?
Is there documentation on regular expression stuff?
Not on regular expressions themselves, because this is a general thing.
Okay.
But actually, this is not true. Now that version 13 has quad S and quad R, which are regular expression operators, we included in the documentation for regular expressions, because that was part of the license agreement, so it's part of the documentation. And also, if you want to replace, you can also, there's a user command called freplaced, and you can, for example, put 2 things. I would like to replace all these names here by another name. Let's say that you don't like this name in all this folder, in all the files that have this extension. I want to replace all the names in it. You can do it. Then all of a sudden, all these names will be replaced by another one, if that's the way you want to do it. So it is just there. I have a workspace here. I want to show you. Here's a function called compare. It looks pretty complicated. It seems to be doing some work. I have no idea. It makes some function calls somewhere. Well, it's too complicated. Let's try to figure out. Oh, yes, it does a lot of things, eh? So this is trying to tell you from the top to the bottom. You're asking for all the function calls that this function makes. So I said, give me all the function calls that compare does. It says, well, at the first level, compare is used. And here's a little bit of the comments of the function. Then at level 2, compare calls clear file. And here's a comment about clear file. At level 3, clear file calls SS. And it doesn't call anything else. Then at level 2, it also calls Windows, and so on, and so on, and so on, and so on. So you can get a detailed list of all the functions that are called by another function. You can also get the variables, you can get all kinds of details if you want to. And if you don't like the format that it is, you can add the switch tree view, and instead of appearing like this in a format like this, it appears in a tree view like this, where you can actually remove some of the lines and so on and so on. So you can see here compare calls clear file, which calls SS. It also calls Windows, is enclosed, RLB, compile calls cut, parse, and so on and so on and so on. So you can get a detailed list of all the functions that have been called by another function and so on and so on and so on. So that user command is can be quite useful if you're looking for if you want to do function tree analysis. Let's say I have two functions, I want to compare them. I just want to see what the difference is between the two. So you give the name, you see fin compare, you give the name of the two functions, and then it gives you a list of all the differences. For example, line 0 has been replaced by this one. Well, it's normal, the name is different. And then line 15, so here there's a gap between 2 and 49, you're not being shown all the details, there's no changes in between. So starting at line 51, this one has been removed and has been replaced by this one. So it's a little tool to give you the difference between two functions. There's another one also for variables. So this one, instead of being fin compare, it's var compare. You have two variables. The same thing again. It says this line has been removed, been replaced by this one, and so on and so on. Let's say that I create now a function foo, whatever. It's not important what it does. I now erase a function in my workspace. I edit a function here which I modify, so I replace this by some, okay, that's good. And now I'm going to save this into a different location, simp.ex1. So now I have two workspaces. I have the workspace that I just loaded and a workspace that I just modified. I want to know what's the difference between these two workspaces. Well, I created a function, so that function should be in the new workspace. This one should not be there, and this one should be different. So if I ask to see the difference between the two workspaces, it says there are 92 common objects. Here's the list of them. The function catenate has changed, and if we go up there, it will tell you that the function, there are two outstanding objects in this function, in this workspace. These two, this is the one I read at the beginning, this is the one that I erased, remember? And there are 9 outstanding objects in the other one. I must have modified the workspace in between. I can't remember what I did. But this is basically what it does. It tells you, it's comparing this workspace with this workspace. It tells you the difference in bytes. It tells you the objects that are outstanding in one, the ones that are outstanding in the other, and finally the difference between the two. If you want to know what are the functions like a certain pattern, for example, I want to know all the functions like S something. So it lists all the functions that are available following the pattern. All the ones that end with S, there's 5. All the functions that start with a C and end with an S. And as you can see, I capture the result here. This is one thing you can do with user commands. Normally the display is, the result is displayed in the session, but in this case here, I capture the result and I put in variable Z. And if I now ask for what is Z in its shape, it tells me there are 2 functions with the following pattern. You could also do something like, if you do fins, it will show you all the functions that are in your workspace. If you want to see it with formatted, you can put it this way, and then it formats it nicely in your window there. This is another way to have right pair fins, if you want. You can also have all the functions that start with C star, so it gives me all the functions in nicely formatted this way. And you have the same thing for variables like, names like. Names like is a little bit different in the sense that it returns you the names followed by the name class. So name n lines is a name of class 2, nl to solve is a name of class 3, ns to script is a name of class 9, and so on and so on. Okay, let's look at COMP, something that is, if you look at this function here, you can see that the comments are all, there's comments starting here, there's another one there. The comments are not aligned. So if I wanted to align all the comments, I could say comment align all the functions that start with C and format it nicely so I can see the result. So now if we look at comp CM, if we look at it, you can see now that comments are all aligned by default comp 4. Some people like to align their comments. This is where you can do that. Here's another one, comp bool. If you look at the title, all the variables are in various orders. Some people like to have their local variables ordered. So
if we call reord or locals with a C star as a pattern and we want to format the result, we get this, and we can have a look at comp bool again. We can see that all the variables have been resorted in the header.
okay, this gives you the size of the variables in the workspace. So it tells you that this ns2 script, it takes 132K, gives you decreasing order.
We can also get the top 12 variables.
Here's another one. It's I create a form. I want to know what are the properties of F. So it tells me all the properties, the position, the size, coordinates, the child list, the event list, the prop list, and so on and so on. So this, if you have an object and you want to have details on it, this is one way to do it. If I want to know the latest functions since 2011-9.1, that tells me the list of all the functions that have been modified since that date in my workspace. So, so if you're interested in the latest changes, then uload. I told you about uload. So you can, you want to load a user command. So the user command fun calls is now found in summary. So now if I look in summary, I will find that there's a user command there. And you can see this user command. This file, this namespace contains a series of commands called summary, function call, xref, cd, cdisplays, and so on. And this is all the description for each one of them. And you can see some fun calls is one of the functions that is being used in that namespace.
One command which is interesting is uversion, which supplies information about the APL you're running, the salt version, the user commands, and the .NET version. This could be useful sometimes. Another one which is interesting is cross-reference. xref of a namespace gives you a cross-reference of all the names versus the functions in that workspace. Here the output is a little bit large, so it wraps on several pages, but basically what it shows is that all the names here, alpha, omega, A, AC, ADD, add, del, and so on and so on, if you reference them, if you cross-reference them with the functions down here, for example, CENL, so CENL uses omega as a local variable. So does cut, and example will use a global variable A, and so on and so on and so on. The output is not very friendly, but it can be modified to suit your needs, and is available. Another one which is interesting is Wizlock, workspace locate. Workspace locate searches for anything in the workspace and produces an output. It shows you where, for example, I was looking for arg, and arg was found in scan for you, line 3 in a comment. It was found in cat1 in the comment also, cat2 in the comments, and so on and so on. There's a lot of comments here. A com file was actually is an argument of the function, which is used on line 4, 58, and 69, and so on and so on. We may want to exclude, for example, the comments. And the output here is a little bit smaller, so it only shows the lines that do not include comments. For example, com file and get AMOV. If we want, we can also do this recursively. So it goes through every namespace. So now we have, it includes ns2script, which is a namespace. But as we can see, in some places, in this case here, arg is not what we wanted. It showed us args with an S. So if we want to do syntactic search, we can do syntactic, and it won't include the variables that are not arg exactly. In this case here, we have a hit in the text, so we may want to exclude the text, so we do this way. But as we can see here, there is a problem because this code here is actual APL code, but it was excluded. So we may want to say exclude the text but keep the APL code. And in this case, the text, which is APL code, which is followed by a execute or quadNC or something like that, will be kept as it is deemed to be APL code. This is not foolproof, obviously, but it goes a long way into helping you find out what the problem may be, if there is one. Dyalog also has the ability to perform replacement. Here's another one here where we want to change the code into a variable. The variable is C code, and we may want to change equal by assignment, left arrow. We may want to change the double quote by quote. So all this should become quote, ask again later, quote, space, quote, cannot predict now, quote, space, quote, and so on and so on. So we have to proceed in steps. We have to say change the double quote, comma, double quote by quote, quote, and because these include quotes or double quotes, we have to surround them by quotes or double quotes. So here the double quote, comma, double quote must be surrounded by quotes, and the quote, space, quote must be surrounded by double quotes. Similarly, once we've changed these double quote, comma, double quote by quote, space, quote, we want to change double quotes by quotes. So we say change the double quote, which we must surround by quotes, and replace it by a quote, which we must surround by double quotes. So let's try this. And as we can see now, it's all been changed. The variable has been changed. Dyalog can be used to replace elements. For example, if we have a function in which we want to replace this type of expression by colon if 0 equals quadNC, diamond, the expression here, diamond, and if it is feasible, we can do it this way. We are saying locate, replace anything that is execute followed by a left parenthesis followed by certain number of characters followed by a right parenthesis followed by slash followed by quote followed by any number of characters followed by quote, and replace this by colon if followed by whatever we found here, diamond, whatever we found there, diamond, colon, and if. And for the sake of the example, we're only restricting the change to this function here. It's in replace mode, and we're using a pattern. So now if we look at the function if example, we can see that the change has been made. Simple replacement can be made. For example, I want to replace xz by abc in replace mode in the function if example. We can now have a look at if example, and xz has been changed by abc. We can also replace underbarred letters, for example. If you look at the function fun with underbarred letters, it looks like this. This may have come from a pre-V11 version of Dyalog APL, and we may want to have a look at this with a different font. If we look at this code with a different font, we can see all the underbarred variables. Now, we may be interested in changing, we may want to replace C underbar by C, count by count, on by on, work by work, and so on and so on. And we do this in replace mode. And when we do this, and we look at the function again, we can see that it's all been changed. And with the normal font, this is what the function looks like. A lot better.